Hello students, in today's class we are going to discuss this topic that light is a particle or an energy. Now in certain events like reflection, refraction, polarisation, diffraction, we see that light behaves as energy, and those events can be successfully explained by Huygens wave theory. But what about the photoelectric effect? In photoelectric effect, we know that when some kinds of radiation of certain wavelengths fall on a metal surface, then from that metal surface electrons start going out. Electrons start ejecting out of the surface. So if we try to explain this property, this phenomenon, considering light as energy or wave, it will not be so much successful or explainable. But if we take light as the sum of certain particles, which later on are named as photons, then we can explain this event. How? We know in perfectly elastic collision between two perfectly elastic particles. Perfectly elastic particles means the particle during collision whose shape remains same, and the total momentum and energy before and after collision remains also conserved. So when these two particles are completely identical and the second particle is at rest, the first particle is in motion. When it collides against the second particle, it can completely transfer its energy to the second particle, and the second particle starts moving with its velocity and energy. It comes to rest and it starts moving with the velocity and kinetic energy of the first particle. Now if you consider photon as particle, and if the photon on falling the surface transfers its energy to each electron, each photon transfers its energy completely to each electron, then only by following this property of perfectly elastic collision, each electron can move out with its energy, and this photon comes to rest. But for that, photon is to be considered as a particle which travels with the velocity of light. Now if we consider the formulas of energy and momentum with Einstein's modification, so E is equal to mc square. This is the mass in motion, so it is equal to rest mass upon this, and momentum is equal to mass into velocity. This is mass in motion, so it is equal to rest mass upon this. If you cross multiply, so if we consider this particle travels with the speed of light, then V approaches C. For that, the left side of these two equations will become 0. That implies to m naught c square is equal to 0 and m naught v is equal to 0. To keep this equation as true, these relations as true, the right sides also will become 0. If this will become 0, the right side is also become 0, should be 0. And to become this 0, m naught must be 0. So from these conclusions, from this extraction, we can conclude as m naught is equal to 0. What does this refer? This refer as this, that when a particle starts traveling with a speed equal to light or approaches the speed of light, that only can happen when its rest mass will be 0. So a particle whose rest mass is 0 travels with the speed of light. So if you join these two conclusions, then you can conclude, you can consider light as the sum of particles. But what kind of particle? The particle whose rest mass is 0, which has no rest mass, a massless particle. A particle which is composed of energy, but it has no mass at rest. So this, if we take into consideration this relation, E square minus P square C square. So what about E square? E square is m naught square C4 upon minus P square C square. If you take this m naught square C square common, then you will get C square minus V square upon 1 C square minus V square upon C square. So it will be m naught square C4. This is a very useful equation. Because if you take photon as light particle, okay, if you take photon as particle which travels with the speed of light, but an extraordinary particle which has no rest mass, that means m naught is 0. So this equation will become this, since m naught is equal to 0. From this we get this one. So this particle which has rest mass and travels with the speed of light has a finite amount of energy and also has a finite amount of momentum. But these two should be same, should be equal. This energy, finite energy. If this particle has finite momentum, then this particle has finite energy. If this particle has finite energy, then it has finite momentum. Not infinite, finite energy and finite amount of momentum, but rest mass is 0. Now, if this particle, during photoelectric effect, we can see this particle fall on the metal surface in the form of wave. So it can be considered as in wave form. That means it is a particle which travels with the speed of light, and during the motion it can also show its wave form, its energy character, its wave character. So it also have wave nature. So if it has wave nature, then it must follow this relation also. H nu E is equal to h nu, where h is Planck's constant. Planck's constant. So it can also be written as hc by lambda, where lambda is that wavelength in which that kind of particle which has some amount of finite amount of energy and some finite amount of momentum, but has no rest mass, and it travels with the speed of light. And when it travels, it can form a wave whose wavelength is that lambda. So E upon C, from here we can write E upon C is equal to P, and that P is that finite momentum of that light particle, photon. So E by C is equal to Planck's constant by wavelength. So comparing these two, we can write that the momentum of that particle is Planck's constant upon lambda. This wavelength is called de Broglie's wavelength. The scientist who first made that daring attempt to say that light is also can be considered as a particle, and also at the same time that particle can show its wave nature. Okay students, bye bye.